This is a little reminder on how to balance equation for those people who might want a little extra help with it. So I'm going to begin by reminding you of a few things. First of all, you might recognize this element is what? So it'd be bromine, this element, iodine. What's that element? Nitrogen, this element, chlorine, this element, hydrogen. You all recognize oxygen, and of course fluorine. Now if you read that, it says Brinkelhoff. So all this together, Brinkelhoff. Those are elements that when they are alone, they occur in pairs. Okay, so I'm going to write down pairs when alone. Now alone means not in combination with something else. Then to balance the equations, we had 3 steps that we said you need to consider. The first step was to, I've lost my connection with my tablet. All right, here we go. So the first step was to write the symbols. The second step is to write the formulas correctly. Formulas. And the third step is to balance the equation. Symbols are self-explanatory. Formulas require that you know the charges or oxidation states of the elements, and then you have to use subscripts. And when you balance, you have to use coefficients. All right, so here we go. First of all, symbols. So you'd have Al, you'd have HCl, yields is an arrow, aluminum chloride is Al and Cl, and hydrogen is H. Step 1 done. Step 2, formulas. When you do formulas, you got to use subscripts. So you don't have to do anything on the aluminum because it's by itself. It's not on the Brinkelhoff list. It has 0 charge because it is by itself. So you just leave it alone, just Al. But hydrogen's +1, chlorine's -1. So you have to consider, is that formula correct? Well, yes, because of +1 and -1 cancel each other out. The total is 0. Aluminum is +3, chlorine's -1. And there you're going to have to make an adjustment. So if that's a 3 and that's a 1, you're going to need to multiply this one by 3. Okay, so we've got a -1, you got to multiply by 3, so that 3 times 1 is equal to the +3. Hydrogen's by itself, so its charge is 0, but hydrogen is on the Brinkelhoff list, so it has to be H2. Now we've done step 2. We had the formulas correct. Now to balance the equation, you're going to need to use coefficients. Coefficients are the big numbers that go in front. So your first inclination might be to say, well, aluminum is okay because there's 1 atom of aluminum here, and there's 1 atom here, and they're even, and that's what they're supposed to be, even on each side of this arrow. So they're good. The chlorines, though, are not good. So we have a 3 here, and excuse me, we have 1 here, and we have 3 over here. So you might be tempted to put a 3 there, and that would make the chlorines right. So you got 3 Cl's, because 3 times 1 is 3 Cl's. Remember, 3 HCl's means 3 HCl's. HCl, HCl, HCl. So there are 3 H's and 3 chlorines. Over here we have 2, so there's nothing I can multiply 2 by to get 6 or to get 3. So I'm going to have to go to a higher number, which is 6, because 3 and 2 both go into 6. So I could put a coefficient of 3 in front of the hydrogen over here. Now I know that 3 times 2 equals 6. That means this needs to be changed to a 6 instead of a 3, so I'm just going to make it a little sloppy, but now it's a 6. And that would give us 6 chlorines as well, because now we have 6 HCl, so HCl, HCl, HCl. There are 6 of them, so 6 chlorines. On this side there are 3 chlorines, so I need to multiply that by something to get 6. That would be 2. When I put a 2 in front of the aluminum chloride, that's 2 of these AlCl3s, so it means I have 2 Als. So you got to fix that over here, and then you are finished with that equation, and it's complete. For the second one, we're going to do the same 3 steps. I would suggest that you try it before I write it down and see if you can work it out, and then follow along as I do it. All right, so magnesium chloride, hopefully you've tried it by now, is Mg, and it's magnesium chlorate, and then ClO3. Now, for those of you who are new, the ATE ending means that you will find that symbol at the bottom of your periodic table on the list of polyatomic ions. Yield is an arrow. Magnesium chloride is Mg with Cl plus oxygen. So now we have our symbols complete. Formulas. When you look at your periodic table, if you need one of those, go to my website, halchem.net. On the front page is a link to a periodic table. This is -1, plus 2 minus 1, so I'm going to need a parentheses and a what? What goes outside the parentheses? A 2, because 2 times 1 matches that 2. Over here, this is a plus 2, that's a -1, so what needs to go down here? And then oxygen is on the Brinkelhoff list, and it's by itself here, so it has to be in pairs. Now we are ready to do the third step, balance with coefficients. So you look over at the magnesiums and say, well, there's one, so we're good. You look at the chlorines, how many chlorines do you see here? I'm hoping that you said 2, because the 2 applies to everything that's inside the parentheses. Inside the parentheses, there is 1 chlorine. So since there's now 2 of everything that's inside the parentheses, that means there's 2 chlorines. And over here, there are 2 chlorines. So we're good. How many oxygens are here? And there are 2 outside the parentheses, but there are 3 inside the parentheses. So what is 2 times 3? So that would be 6. So on this side, I need to multiply 2 by something to get 6. So if I put a 3 there, we've now completed that one. I'm going to skip number 3. Number 3 turns out to be balanced pretty easily if you just write the formulas correctly. You don't have to do anything else. But this one requires coefficients, so I'm going to go ahead and do it. So aluminum nitrate, we'd have Al. Then we'd write nitrate down, NO3. Sodium hydroxide to be Na and OH. And once again, I'm finding these symbols on the periodic table. Aluminum is an element. Nitrate's at the bottom of the table because it ends in ATE. Sodium is an element. Hydroxide is actually at the bottom of the element, even though it ends in IDE. You may remember that there were 3 common polyatomic ions that end in IDE. One of them is hydroxide, another one is cyanide, and another one is peroxide. We used peroxide in the lab that we did last Tuesday and Wednesday. All right, so now we yield sodium nitrate. So you might note that once you have this side finished, these symbols will be the same. You don't really need to look up the symbols again. So NO3 and Al and OH. So now we've done the symbols. Next step, formulas. So this is a +3 charge and a -1. So the 1 needs to match the 3. So how many NO3 groups do I need to match the +3? You're going to need 3 of them. So you put parentheses around it and then a 3. Okay, sodium hydroxide, Na is +1, hydroxide is -1. So your formula is good. Na is +1, nitrate's -1, so that formula is good. Al is +3, hydroxide's -1. That formula is not good. So I have to have 3 1s to match a 3, so I'm going to put a parentheses around it and then put a 3 outside the parentheses, because the 3 needs to apply to both the O and the H, because together they make hydroxide. Now we have the formulas done correctly using subscripts. Ready to balance. 1 aluminum, 1 atom of aluminum, so we're good. 3 nitrate groups. on this side, how many nitrate groups do you see? Hopefully we didn't say 3, because it's very common for people to say that there are 3 nitrate groups, but there's only one group. There's no parentheses. If there were 3 groups, it would look like this. You'd have 3 outside of a parentheses. So you've got 3 nitrates on the left side, 1 nitrate on the right side. You're going to need to put a 3 there to make them balance. That, of course, creates 3 sodiums. On this side, there's only 1, so I need to put a 3 there to make it balance. That, in turn, creates 3 OH groups. But if you look over here, you have 3 OH groups, and so everything is balanced. All right, I'm going to do one more example. Aluminum, chlorine, and aluminum chloride. Those are the symbols. Charges and formulas, that's 0, that's 0, this is plus 3, that's minus 1. If that's a 3 and that's a 1, we're going to need 3 down here to make the charges balance. This is chlorine. What's special about chlorine? Remember, it's on the Brinkelhoff list, so it has to be Cl2. So AlCl3 and Cl2. Then we need to balance the equation. You don't have to do anything with the aluminum because it's not on the Brinkelhoff list and it just exists as an individual atom. So what's uneven? 2 chlorines, 3 chlorines. I need a common multiple, so what's going to go here? If you put a 2 there, that makes 6 chlorines, so that means you need to put a 3 here. Now the consequence of adding a 2 in front is that you created 2 aluminums as well as the 6 chlorines, so the 2 aluminums need to be balanced by putting a 2 over here to make 2 aluminums on that side, and now we have finished balancing the equation. All right, I'm going to stop it there, post this, and hopefully that helped you. These are not specific questions that you're doing, but they are like those that you're doing, and you do them all the same way. Symbols, formulas, and balance using coefficients. Don't forget about Brinkelhoff.